Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. Your helpful professor that wants to help you pass either physics or calculus. Keep in mind, I'm always bitching about calculus because calculus should only be taught to math majors. It should not be taught to engineers or doctors or dentists or anything else, in college. It's a waste of time. It's like teaching you, making you take 3 semesters of Sudoku puzzles. Those puzzles in the back of the magazine there as you're waiting for a plane to Phoenix. Or 3 semesters of crossword puzzles to learn the English, Or 3 semesters of Rubik's Cube. Or 3 semesters of juggling. All extremely difficult things to learn and everything else. But when you're done, you've done nothing. They're unuseful. And that's exactly what calculus is. It's as unuseful as imaginary numbers in mathematics. And calculus is important for mathematics because it's pretty interesting the way all this works, but it should not be taught to engineers or anybody else except mathematicians, So that said, this problem here is going to be fun because I'm going to show you about as hard. This took me a month to program. Figure out exactly how to do it step by step and how to show you a step by step on the problem. And it's a good indication of how difficult doing integrals is and how tricky they are, whatever they are. My theory, remember I reprogrammed this calculator years ago, 25, 30 years ago, when I was an electrical engineering major at San Diego State and in California here. And I was able to program the calculator to do step-by-step calculations, for my problems. I did it in electronics. I did it in whatever test I had in college. I don't care what it was. I programmed lasers, mirrors, convex, concave mirrors, electronics, circuits and capacitance and coils and stuff like that, doing circuits in parallel and series. Whenever I needed, my theory was, why take notes on a subject if you can program the calculator and be able to do it perfectly, So that's what I was programming for, And then I decided to, after I got out of college, to sell the programs, and I've been doing that for a long, long time, But I always just programmed calculus tests and physics tests. I wasn't interested in programming every damn thing that was involved with calculus, But I went crazy on this problem here because because of COVID and being locked down, or not even locked down anymore, but I mean certainly, at home all the time thinking what you're going to do and how you're going to do it. And I was cleaning up a lot of this stuff when a person texted me and says, hey, what about this problem? It doesn't work on this partial fraction decomposition. So then you get into it and you find some errors and you find how you did it back when, and you should do it better, make it better for the students, and etc. So that's what I've been doing. So let's do this problem here. Anytime you can factor the denominator on a problem, you should be using partial fraction decomposition. Of course, how to factor the denominator on any problem is not easy for anybody, let alone, mathematicians. You have to study it and be into it all the time to be able to do it efficiently. Of course, the calculator will do it automatically for you, this beautiful calculator of TI-92 or TI-89, and then I always use the TI-92 Plus calculator, which is the greatest calculator they ever made, but they've changed it now to the titanium, which we have now, and it's pretty nice too, being so small and compact. But I would have never been able to program if it was just this titanium calculator to be used. I would have never been able to do it, but I was able to do it with the TI-92 Plus calculator, which you can still buy them, on internet. Get yourself one. It has a keyboard. It's a beautiful calculator. So anyways, this partial fraction decomposition problem. Index 8 to get to my main menu. You buy my programs, of course, and I email the programs to you and you download them into your calculator, titanium calculator here. And then you're told how to put index 8 into here with the open and close parentheses, which tells the calculator you want to do a program. And so then you're on your way. And so then up comes the main menu. Now you scroll with this clover leaf here down. You press second, and then if you want to go screen by screen, you press second. It goes really fast through. There's about 180 menu items here, maybe 200 items up and down, so there's quite a lot of information here for calculus. Whatever they ask you on a test would probably be in here. I'm already at partial fractions to save time, so I'm going to press that. And we're going to enter this integral here, 8x cubed. Make sure you put the parentheses in it. Parentheses are extremely important in math. Tell the calculator and your own brain what you're actually doing, what's enclosed in the parentheses, what are you doing, you know. Without the parentheses here, you'd just be taking 16x divided by this, and it would eliminate these here. So you have to put it in parentheses to make sure it knows exactly what you're doing. I have programmed it already in here so that, because if I try to do it with the simulator here, sometimes it screws up. I've had many cases where I'll get all the way to the end and the thing will just lock up on me and not be able to put the thing in. So I've already put the program, you know, the integral in here. You can see it here. You're going to press alpha before you put these numbers in or letters. In my programs, you have to press alpha. Here's alpha. You have to press it once, and then you put all the characters in here, just like no problem. And then, of course, I give you the chance to change in case you made a mistake. It doesn't look right, you can change it, but I say it's okay. So we'll move on. I factor the denominator for you, which is x squared plus 4 over x squared, and this is a certain way of doing partial fraction decomposition because of the way this is structured here, the denominator being factored. So we set up the problem. We're going to multiply the left. Here's, you know, the left of the numerator and stuff like that. We're trying to, you can read this, but you multiply both sides of the equation. The left side of the equation here, we're going to put in being this whole integral here, and then of course the right side of the equation is going to be where we change it to the partial fractions, which is ax plus b, or whatever the factor denominator tells us or makes us do, you know. And of course, if you did this in a test, you're supposed to remember all that. You're supposed to memorize that, you know, nonsense. In this case, the answer is more complicated than the original integral. Remember, an integral is the area under a curve. You know, you can graph this and show it on a graph, and it'll come up with a parabola, you know, whatever. And then the integral finds the area within a certain boundary range, which is not in this is not a definite integral where you're given the range, or you choose the range to find the area under the curve. This is an indefinite integral, of course. You're going to end up with a plus c at the end, where you have to figure out the constant that you're supposed to use at the end to figure out the problem. More nonsense. Calculus is completely useless in life, you know. That's what I found. The guys who wrote the calculus books are absolute geniuses. I hope that they're millionaires many times over, because it's unbelievable what they've programmed, you know. Larson and Hostetler I use as the calculus. 1,300 pages of genius stuff in there, that mathematics, you know. But man, oh man, can you imagine us deciding to write a calculus book of 1,300 pages and getting it all printed right and all the figures exactly right and the minus signs correct, and unbelievable endeavor, you know, but they've did it. Of course, these programs that I've done, I'm the only one in the world that's done this stuff, and this is extremely difficult and great too, you know. I do most of what's in the calculus book in the calculator here that you have in your purse or your pocket, depending upon whether you're a man or female. Oops, sorry, the gender thing is not right. So anyway, here's the left side of the equation, and we're going to multiply it by the denominator here. And to get rid of the denominator, actually, that's what we're doing. And then we're going to create the right side of the equation with our partial fractions, just like you would in a test problem. And we're going to multiply that side by the denominator here to get rid of the denominators. Okay, so we make, when you have an x squared here, you got to put an a times x. Okay, here's x squared, and this one you got to put c times x. If it wasn't for the squared here, you just put a. If it wasn't for the squared, you just put c. Okay. But anyways, ax plus b, cx plus d is the partial fractions for this one. And then we're going to use algebra to divide into what we've multiplied to simplify the problem. To eliminate the denominator of ax plus b, we multiply it times this right here, this, and we get up, then you're going to come up with ax plus b times x squared plus 4, okay? And to eliminate the denominator of cx plus d, we're going to multiply that times the denominator here. And of course, when you multiply that, it cancels, so you have just cx plus d. Imagine the guy who determined or who found out about partial fraction decomposition without calculators or anything, and just studying it, or even thinking it's possible, or even, you know, must have really been a nutcase, huh? Mathematician to do this. So anyways, here we have the left side here, and we have the right side. Okay, all in one screen here. Now we're going to multiply ax plus b times what it's, the quantity here, x squared plus 4. Okay, and we're going to do that with the FOIL method. Remember that from algebra in previous classes? The FOIL method, F-O-I-L. First, outside, inside, and last. We do that here, and we come up with this right here. ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Now we're going to combine the like terms, so we're going to get ax cubed plus bx squared plus 4a plus c times x plus 4b plus d. We're going to eliminate the coefficients of the numerator, or not eliminate, but equate them. Okay. So on the left side we have 8x cubed. Here on the right side we have ax cubed. So a has to be equal 8. Here's on the left side 3x squared. Here, right here, 3x squared. Here's a coefficient, and here's bx squared on the right side. So b must equal to 3. On the left side we have 16x plus 4a plus cx. So always 16 equals 4a plus c, because the x's cancel, right? And then we're going to sub in a. So we sub in 8 for a. 16 equals 4 times 8 plus c equals 32 plus c. We subtract it from the left side. We come up with c is equal to minus 16. Now, 8 is equal to 4b plus d. In other words, the constant, right? 0 is equal to 4a. There's no constant here for in the left side, so that's equals 0. And that's going to equal 4b plus d. So we sub in b, which comes in 3 here, and we do 0 equals 12, you know. Subtract 12 from the other side, and we get d is equal to minus 12. Okay, so we found all the coefficients. So here's the original partial fractions. We're going to sub in 8x plus 3 minus 16x plus minus 12. All over the denominators here that we've figured out before, right? We're going to set up the integrals. The integral of 8x is x squared plus 4. That's the first one. Next one is 3. You know, we have 8x plus 3. So 3 you can use the common denominator, 8x squared plus 4. There's the second integral. We have minus 16x over the denominator here, and we have minus 12 over the denominator. Okay? 4 integrals. So we're going to integrate the 4 integrals here now. So we're going to, the first integral, 8x over x squared plus d, that's use substitution. We bring the constant always out of an integral before we integrate it. We set up the u is equal to x squared plus 4, du is equal to the derivative here of x squared is 2x dx. Bring the 2 divided the other side, okay, equals x dx. Now notice that x dx eliminates because it actually equates the numerator with x dx, you know, so they are eliminated in u substitution. Now we put in the u's, 8 times the integral of 1 over u, du plus 2, that's what the dx equal, remember, from before. So we have to divide by 2 here to equal 4, equal 1 over u du. And we back sub u, which equals, if the answer is 4 times log of x squared plus 4 plus c. Now the second integral, 3 over x squared plus 4. Now this one doesn't use u substitution. You're supposed to memorize this stuff now for tests and be a genius at calculus, you know, in the nonsense class. And we have to use an integration rule on this, which is on page 384 of your Larson-Hostetler book or something. You know, they got a million of these in there. Again, we bring the constant out, but here 1 over the x squared plus 4 dx, well, that we use the integration rule here. 1 over a squared plus u squared du is equal to 1 over a tangent of arctangent of u over a plus c. That's one of the rules, okay? Supposed to memorize that now for a test. Very important. A squared equals 4, so a equals 2. U squared equals x squared, so u equals x. We sub that in. We sub it in here, okay? And then we integrate. Comes up with 3/2 times tangent of minus 1 x2 plus c. Third, minus 16x over x squared plus 4 squared, quantity squared. We use substitution at the beginning. Constant out of integral. And we can set up the, you notice we have x dx. We're trying to use substitution. You're supposed to do the derivative of what's inside the parentheses here. Do it really quick. We know that if you know your derivatives, x squared is equal to 2x, okay? So then that you can kind of match that to the outside. If you can, then you can use u substitution. So remember, we're trying to get x dx eliminated. Well, u is equal to x squared plus 4, du is equal to 2x dx, divides, we found out x dx right here. We're going to substitute du divided by 2 for that. We put it in the integral, substitute u. Here's du for the dx. And we divide minus 16 by that. We get 4 plus the, and 4 times minus 4 times 1 over u squared du. The integration of 1 over u squared is minus, which eliminates the minus sign, and 1 over u. You knew the integral of that, didn't you? 1 over u squared is equal to minus 1 over u. I can show you step by step how to do it, but it's a waste of time, really. So it's 8u plus c. We back sub u. The answer is 8 divided by x squared plus 4 plus c. The fourth integral, minus 12x over x squared plus 4 squared. This is a wild one, huh? Reduction formula. Okay, that's how you solve this one. Notice that this is the same as a u substitution, except there's a square here over in the denominator. Okay, so that you can't use u substitution. You have to use this reduction formula. Constant out of the integral again. We're going to apply the formula. Here's the formula. 1 divided by 2 plus a squared times n, etc., etc. Notice you're supposed to know this by heart, right? A squared equals 4, a equals 2, u squared equals 4, and we got n equals 2. We substitute all those into the reduction formula here. We simplify, minus 3 halves. We do the calculations. Now you're just writing this stuff on your paper if you ever did it for your homework or for your careless about what the calculations are. But these are all exactly correct, but we simplify more, keep whittling it down here, and more. And then we have to integrate the last integral, which now is the integration rule. 1 over a squared plus d squared equals 1 over a times tangent arctangent of u over a plus c. Again, we put that in here. So 3 halves integral of this here. Integrate, and here's the answer, minus 3/4 times arctangent minus 1 over x over 2 plus c. So this problem here has two answers. This problem here, which we just integrated, minus 3 halves times x over 4 plus or minus x squared to the 1 power, minus 3/4 times arctangent of minus 1 x over 2 to c. Now I can program to get rid of this 1 here. Notice this is, but I didn't take time to do that. It's enough bullshit the way it is here. So the problem, original problem is here, and here's the answer for the original problem. 4 times log over 2. Here's each one of these that we've just computed. Right? Wasn't that fun? Look at the answer compared to, and all of them plus c. You have to figure out what the hell plus c is. In the Larson Hostetler book they have, I use calculus so much. I bought a exercise company, and I used it extensively when I tried to figure out how fast a bike was working, and designing the bicycles for the exercise. They tell you crap like this in the calculus book, but I guarantee it does nothing useful, in solving any problem. It's never used in space, never used in anything, And we go back to the menu and do whatever you want to, you can go back to the main menu and do the next problem in the test, whatever, Hey, good luck in your classes. Remember, I'll help you. I'm interested in you passing calculus or physics. The physics programs are unbelievable, so don't pass them up. Certainly go look at them a little bit if you would. everystepphysics.com. And you can email me the tests or quizzes. I'll show you how to do them in my, on the calculator, and show you everything. If you can't load the programs right, I'll help you with that. You can call me. I'll talk to you. Whatever. But anyways, I'm interested in you passing calculus. So go to my site, buy my programs, and you'll have them in the calculator for the rest of your life. And you never know, what happens in your life. You marry somebody or your partner or whatever. They're going to take some sort of calculus class in the future, or if your grandkids take it, or your own kids, or whatever. You'll be using calculus in the future, and then you have it all in the calculator here. You can throw out the Larson Hostetler book. You'll never learn anything from that thing. But you'll learn a lot from this one, okay? So good luck in your classes, and, be tuned for the next. Subscribe if you want. Subscribe to the thing. You'll see next bitch about calculus, or my next feed of programming, okay? Good luck. Have a good one.